Hi everyone, so welcome to today's video. Today's video we're going to discuss chapter 6 form 5 additional maths, permutation and combination. But for today's video we specifically will be discuss on how to solve some problems of permutation. Okay, so today we're going to discuss two questions. Okay, so we look at the first one. Okay, how many different odd numbers more than 30,000 can be formed from the digits 1, 2, 3, 4 and 5? So in this question, it wants us to form an odd numbers that more than 30,000 from the digit 1, 2, 3, 4 and 5. Okay, so we look at the questions. Okay, so basically we have 1, 2, 3, 4, 5 digits. Okay, if we want odd numbers, okay, the last digit must be either 1, 3 or 5. Okay, and the first digit, okay, to make sure it will be more than 30,000, the digit can be either 3, 4 or 5. So in these cases, there are several cases that we must consider. The first case, okay, we write 1, 2, 3, 4, 5. So the first case we consider as the number will be start with digit 3. Okay, so we state the first digit number must be start with 3. So you know 3 is a odd numbers. So the last digit only left us with 1 or 5. So what option we have for the first digit? We only have 3, right? So we only have one choice. Okay, the last digit is either 1 or 5, so we have two options there. Okay, at the beginning we know we have 5 digits. Okay, we already choose 1 for the first part and 1 for the last digit, so we only left with 3 digits to put in the middle here. Okay, so we know that the first place we have 3 options, and then we have 2, and then we have 1. So the first case, okay, how many ways? So the answer will be 1 times 3 times 2 times 1 times 2, which means we have 12 ways. Okay, clear? Okay, for the second case, okay, the number will start with 4. So we do the same as the first case. Okay, so the first digit we put in 4. Okay, so it gives us the last digit 3 options. So 1, 3 and 5. So the first part we put in 1. The last digit we put in 3, because we have 3 options, either 1, 3 or 5. So it left us with, okay, the middle digit will be 3, 2 and 1. So the number of ways is 1 times 3 times 2 times 1 times 3, which is 18 ways. Okay, and the last part, okay, last possible case is start with 5. Okay, so same thing, 1, 2, 3, 4, 5. Okay, so the first digit is 5, which means we only left with 1 and 3 for the last digit. So how many choices we have for the first digit? So only one choice, which is only 5. The last digit we have 2 choices, either 1 or 3. So which left us with 3, to 1 for the middle digit. So the number of ways is 1 times 3 times 2 times 1 times 2. 12 ways. So total number of ways, okay, to arrange, okay, odd numbers more than 30,000 from digit 1, 2, 3, 4 and 5 is, so we have 12 ways plus 18 ways plus 12 ways. So it will give us the answer 42 ways. Okay, so that is how to solve the first question. Okay, now we move to the second questions. Okay, find the number of ways if Stefano wants to arrange 3 physics books and 4 chemistry books on a shelf. The chemistry books are always separated. B, the physics books are always together. Okay, so for the first part, the chemistry books are always separated. So we have 4 chemistry books. And then we have 3 physics books. So it means the 3 physics book can be put in the middle of each chemistry books. Okay. So 4 chemistry books. Okay, at the first place we have 4 options to put the chemistry books. And then after we choose 1 book, so we're left with 3, and then 2 and 1. The same thing goes to the physics books. So at the first place we have 3 choices. After we pick 1, we're only left with 2, and final one is 1. So the number of ways the chemistry books are always separated is 4 times 3 times 3 times 2 times 2 times 1 times 1. So it will give us 144 ways. Okay, so we proceed to the next question. Question B. The physics books are always together. So we have 7 places to arrange these books. 1, 2, 3, 4, 5, 6, 7. Okay, the physics books are always together. So I assume that I tied up all the physics books together. Okay, so we have 3 physics books. So we have 3 options here for the first place, 2 options for the second place, and 1 option for the last place. So this is actually 3 factorial. So the other part, we left with 1, 2, 3, 4 places for chemistry books, and we consider the tied up books as another 1 places. So what left behind this part is 5 factorial. Okay, why it is 5 factorial? So it is because, okay, look at this, we can consider it. For example, this is the chemistry books, this is the physics books, chemistry. So we have 1, 2, 3, 4, 5 movement there. Or the second possible position, 1, 2, 3, the tied up physics books, 4, 5. So 1, 2, 3, 4, 5 possible movement there. Okay, so it will give us the answer 3 factorial times 5 factorial. So 3 factorial is 6, 5 factorial is 120. So which give us the answer 720 ways. 720 ways. Okay, so I hope you understand my explanation on these 2 questions. Okay, if you have any problem, you can simply pause the videos and rewind it from the beginning and rewind it from the beginning or which part that you don't understand, or you can simply comment down below so I can respond to it later. Okay, so I think that's all for today. Thank you very much. Bye.